All right, this is another type of buoyancy problem, right? So let's imagine we've got this sphere and it is submerged in, and its density is 253 kilograms per cubic meter, right? And the fluid is 865. Whoops, the fluid is 965 kilograms per cubic meter. Okay. Now I know that we're going to have to exert a downward force because it should float, right? This is less dense than this, so I know that the buoyant force is more than the weight. Okay, so the forces on this thing are the buoyant force up, and then we're going to have to exert a force down on it, right? And then of course gravity is going to exert a force down. Now, we just have the density. We don't have the mass, right? We have the density and the volume, so that's going to become density times volume times g, which makes it look suspiciously like the formula for buoyancy, which is density times volume times g, right? Understand, though, this is the density of the fluid that we displaced. That's this. This is going to be, of course, the density of the object, which is this. Okay? And that's why we need a little help here, because this is going to be a bigger number than this number, because that number is smaller than this. Okay, so if we set this thing up, we could say that the buoyant force, so rho of the fluid times the volume times g, is equal to some force that we have to exert plus rho of the object times the volume times g. Now this is a sphere, so of course that's 4/3 pi r cubed, right? So density of the fluid times 4/3 times g is some force times plus density of the object times 4/3 times g, right? And now we just plug in the numbers, right? We get 965 times 4/3. Oops, plugging in numbers, 0.14 to the third. Pretend I didn't draw an R there. Okay. Times 9.81 equals F plus, and then this density of the object is 253 times 4/3 times 0.14 times 9.81. Ta-da! Now we're all set. Now we can just solve for this. Now, if you look at this, really, when I do these in my mind, I show you how I do them. Do you see how this is all the same as this, and this is the same as that? And the first thing I'm going to do is I'm going to subtract. I'm going to go this term minus this term, and I'm going to get that, right? So really what it's going to be is it's going to be rho fluid minus rho object times 4/3 pi r cubed times g. And that's what I'll type into my calculator. Thank you very much. So 965 minus 253 times 4 divided by 3 times pi times 0.14 to the third times 9.81. Boom, 80.28. Ta-da!